Let's look at the massive gamble the major AI labs are currently taking to reach human-level intelligence. They believe that if they train AIs on millions of verifiable tasks across diverse simulated environments, the models will naturally evolve into resilient, open-ended problem solvers.
But aren't today's models famously inefficient at learning compared to humans? It feels like they need mountains of data just to grasp basic concepts.
They do. But the labs are betting that scaling up will steamroll that problem, similar to how simply adding more computing power solved early language model issues. The thinking is that the heavy, data-intensive training is just a one-time cost.
What about learning on the job, though? If I hire a human, they get better every day. But an AI's core knowledge is usually frozen after training.
That's where massive context windows come in. Optimists argue you don't need to update the model's actual underlying weights if it can just hold 6 months' worth of on-the-job experience directly in its active memory.
That sounds great in theory, but if they're getting so smart, why is it still so hard to get an AI to just navigate a live website and buy something for me?
That brings up a crucial difference between a task being verifiable versus being grindable. To learn quickly, an AI needs to grind through thousands of parallel attempts in a perfectly replayable simulator, which is easy to do for coding.
But you can't just unleash 1,000 trial and error bots on a live website like Amazon without getting blocked by their security.
Exactly, which means we'd have to build perfect simulated clones of the whole internet just for them to practice on, which is currently incredibly labor-intensive. And this exposes a much larger wall we're going to hit with AI progress.
Because if an AI can't practice a task in a fast, repeatable simulator, it's going to struggle to learn it?
Precisely. You can't safely simulate a multi-year court case, a political election, or building a business from scratch inside a data center. Since those real-world actions take months to unfold and can't be endlessly reset to see what works, teaching an AI to master them is going to be incredibly difficult.
We need to look closely at why the way we currently train AI models might be hitting some serious roadblocks. Right now, a major open problem in reinforcement learning is dealing with real-world environments that constantly change and don't have a simple reset button.
So training an AI in a neat, controlled simulation isn't enough to prepare it for the messy real world?
Exactly, because the real world requires incredible sample efficiency, meaning the ability to learn deeply from very small amounts of unstructured data. AI labs are betting that if you train models on enough containerized tasks, that intelligence will generalize to complex real-world goals, like building SpaceX or running a political campaign.
But does getting really good at short-term simulated tasks actually translate to pulling off a massive years-long project?
That is highly debated, and experts like Dario Amati have noted that training on short-horizon tasks doesn't necessarily mean the AI will perform well over long horizons. Plus, there's a huge issue with what happens when the AI is actually deployed, because all the computing power used to interact with users isn't actually updating the model's core knowledge.
Wait, so when an AI is out in the world interacting with businesses and seeing real workflows, it isn't absorbing that experience permanently?
Right. It's acting like a genius grad student trapped doing classroom case studies who never gets to learn from a real internship. Any new information just sits temporarily in its context window, and unlike human brains that compress experiences into intuition, moving AI knowledge back into its permanent weights requires incredibly inefficient gradient updates.
So to actually bake a new skill into its permanent memory, the AI would need to see the exact same lesson repeated millions of times?
Precisely, which is why current online learning only works for extremely repetitive tasks across millions of users. That means true on-the-job continual learning, where an AI learns the highly specific, nuanced workings of your particular company, remains out of reach for now. Let's explore the fascinating challenge of how AI models manage to learn on the job without forgetting what they already know. This brings us to a deep connection between two critical concepts: continual learning and sample efficiency.
What exactly do we mean by sample efficiency here? Is it just that the AI doesn't have much data to work with once it's actually deployed in the real world?
Exactly. It has to learn from a very scarce amount of live data. And while some researchers try to solve this by changing the model's architecture, the real bottleneck seems to be the loss function, which is essentially the mathematical rule for how the model updates its internal weights after a session.
So we need a smarter way to update the model's core knowledge. What is the best method for doing that?
A leading idea right now is called on-policy self-distillation, or OPSD. You essentially let a model build up a ton of useful context during a long real-world session, and then you train the base model to match the exact predictions of that experienced version of itself.
Oh, I see. You're distilling the valuable experience from that session back into the base model. How is that different from just having the model memorize everything that happened?
Well, think about how humans work. You don't get better at your job by perfectly memorizing the transcript of every single daily conversation. OPSD makes sure the model only extracts the necessary insights to achieve a specific outcome, keeping the update tiny so it doesn't overwrite its existing knowledge.
That makes a lot of sense. It avoids information overload. But what if the model doesn't even have enough real-world interactions to extract those targeted insights?
That leads to a brilliant, slightly speculative idea called dreaming. If the AI can build a solid simulation of reality, it can actually rehearse new skills and try alternative strategies internally.
Wow, so it generates its own practice data? Almost like a person visualizing a game before playing it.
Precisely. For example, a data-efficient model called Efficient Zero can beat humans at Atari games incredibly fast because for every single real move it makes on the screen, it has already played dozens of simulated games in its head to see what works.
Let's look ahead at how artificial intelligence might fundamentally change the way it actually learns and gets smarter. In the future, large language models might rely much less on human data and instead practice inside environments they build for themselves.
So they would essentially be generating their own practice spaces?
Exactly. And it is a speculative idea, sometimes called test time training or simply dreaming. The model would spend massive amounts of computing power to write up a video game-like simulation of a real-world task and then train itself against it.
That reminds me of how AI mastered games like Go by playing against itself.
It is the exact same principle, though simulating our messy real world is vastly harder than learning a board game. If it works, this dreaming could become a massive new way to scale AI capabilities, pushing it beyond its factory training.
What would this look like for someone actually using the AI, say a few years from now?
Imagine you have an AI co-working with you for an entire week on a complex, unfamiliar project. At the end of the week, you review the work and give it a simple thumbs up or thumbs down.
And if I give a thumbs up, does it permanently learn from that specific project?
Yes, the base model distills everything it just learned during that week and immediately starts getting better at related adjacent tasks. It begins learning on the job, expanding its skills far beyond what the developers initially taught it.
That means the AI is continuously getting smarter from every single user it interacts with across the world.
Precisely. And that continuous compounding real-world experience will eventually become the primary way AI improves, which is a massive and slightly intimidating shift from how things work today.